Bismillahirrahmanirrahim. Assalamualaikum. My name is Intan Syamira Ismail and I will be presenting my research project with the title of Evaluation of Manganese Biotic Removal using Cultured Microbiome. A little bit introduction on this topic. Manganese is one of the heavy metal that can be found naturally on Earth, and it is also an essential micronutrient that we use for the growth and survival for animal and plants and human. Manganese are also frequently used in the industry in the making of ceramic, fertilizer, varnishes, and fungicide products. As the demand for manganese-based products to get increasing, the production of manganese waste also increased. Due to the increase of manganese waste in the form of soluble manganese, Mn2+, most of the manganese will end up in soil and surface water that we will be using as our drinking water. There are lots of methods that can be used to remove manganese in contaminated water. One of the methods that can be used is by using the manganese oxidizing bacteria, MOB, to oxidize the manganese into manganese oxide. And the manganese oxide, which is the insoluble manganese. This method is more efficient and environmental friendly. The purpose for this research is to study the manganese removal efficiency of the by MOB isolate from section 7 Shah Alam Lake water, and also to study the effect of pH level on the manganese removal by using atomic absorption spectroscopy AAS and leucobarylene blue dye. For the problem statement, as I mentioned earlier, due to the increase of manganese demand, the production of manganese-based product also increased. And this caused the production of manganese waste to also increase. Most of the manganese waste will end up in soil and surface water that we will be using as our drinking water. And high dose, the high concentration of manganese present in water will bring harm to human, animal, and plant. There are other methods that can be used to remove the manganese, such as by using the psychochemical method to oxidize manganese by using chlorine, but it will produce toxic byproduct. Next is the objective. There are three objectives for this research. The first objective is to isolate the MOB from section 7 Shah Alam Lake water. Next objective is to study the effect of pH level on the manganese removal using the AAS. And the last objective is to investigate the manganese oxidation in sulfur filtrates with the addition of LBB. For this methodology, it is modified from an article written by Barboza in 2017. The article is High Manganese Tolerance and Biooxidation Ability of Cerathiamycin Isolate from Mine Water. So first, we started with the preparation of water samples from Shah Alam's Section 7 lake. We filter 10 millimeter of this lake water, and then we incubate it with K medium for 34 hours. And then we take 0.1 milliliter from the solution and we spread onto agar plate to create a mixed culture. Next, we move to isolation bacteria. From the mixed culture, we take a bacteria from the mixed culture and we do the streaking method on the other agar plate. And we will incubate the agar for 24 hours. This step will be repeated until we obtain a single colony of bacteria. Next is the manganese tolerance. The purpose of manganese tolerance test is to observe the isolate tolerance toward high concentration of manganese. There are three concentrations that we tested. There are the concentration are 50 milligram per liter of manganese, 300 milligram per liter of manganese, and 800 milligram per liter of manganese. Next, we move to manganese removal using AAS. At the manganese tolerance, we choose two isolates that has the highest CFU value, and we do the manganese removal. For the manganese removal, we will incubate the isolate in the nutrient broth that contain manganese for 7 days. At day 1, day 2, day 3, we will take some sample from the nutrient broth and we filter it to be analyzed using the AAS. Lastly, we move to manganese oxidation using the LBB solution. First, we have to make the LBB solution because the LBB comes in powder form. The procedure for the LBB solution were taken from Crombie and Altman in the article year 1974. For the manganese oxidation, nutrient broth that contains the isolate manganese were incubated for 7 days, and after 7 days, we filter. We take some sample from the nutrient broth, and then we filter it, and then we will mix with the LBB solution. The changes in the sample were observed. For the result, for the accession of bacteria, we succeeded to obtain 6 isolate, which are INAB10, IHKM06, IHKM15, NAKM01, IHKM10, and INAB03. Next is the manganese tolerance test. As I mentioned earlier, there are 3 manganese concentration that were tested, which is 100 milligram per liter, 300 milligram per liter, and 800 milligram per liter. For concentration 50 milligram per liter, the top 2 CFU value for that were gained is by HKM10 with the CFU value of 6.3 times 10 to the power of 9, and IHKM06 with the CFU value of 4.4 times 10 to the power of 10. The next concentration is 300 milligram per liter. The isolate that has the highest CFU value for this concentration is INAB10 with the CFU value of 2.04 times 10 to the power of 10, and IHKM06 with the value of 4.16 times 10 to the power of 10. Next, the last concentration is 800 milligram per liter. The isolates that has the highest CFU value is INAB10 with the value of 3.67 times 10 to the power of 10, and IHKM06 with CFU value of 5.13 times 10 to the power of 10. So for the manganese removal, the isolate I have chosen to be proceed with manganese removal is INAB10 and IHKM06 because it has the highest CFU value on all concentration. For the manganese removal, for INAB10 at pH 6, at first, there are no manganese removal occurs from day 0 to day 1. And I assume that during this time, the bacteria are in the lag phase. And from day 1 to day 3, there are high rate of manganese removal, and then I assume that from day 1 to day 3, this bacteria already enter the exponential phase. Next is for pH 7. From day 0 to day 1, there already has some manganese removal occurs, and it continues to remove manganese until day 3. For pH 8, from day 0 to day 1, they has the highest manganese removal when compared to other pH level, and then the removal of manganese continue until day 2. But from day 2 to day 3, the manganese removal has slowed down. I assume that from day 2 to day 3, the bacteria already enter the stationary phase. For the overall manganese removal, the highest overall manganese removal for INAB10 occurs in pH 7 with a percentage of 75.3%. Next, we proceed with manganese removal for IHKM06. For pH 6, from day 0 to day 1, there are slow rate of manganese removal occurs. And then from day 1 to day 3, it continues to remove manganese faster. I assume that from day 0 to day 1 is in the bacteria is in lag phase, and from day 1 to day 3 the bacteria is in stationary phase. For pH 7, from day 0 to day 1 there is no manganese removal occurs, and it started from day 1 to day for the manganese removal started from day 1 to day 3. So I assume that from day 0 to day 1, the bacteria are in stationary phase, and from day 1 to day 3, the bacteria is in exponential phase. For pH 8, the manganese removal occurs. The manganese removal for day 1 is also the highest when compared to other pH. Same goes to INAB10. And then the removal for day 1 to day 2 has slowed down, but it kept removing manganese until day 3. For the overall manganese removal, the highest overall manganese removal is at pH 7 with a percentage of 75.7%. The reason why pH 7 is suitable for manganese removal is that in a study by Elvis and Lacombe in the year of 2022, the pH range that they obtained that has the highest manganese removal also in the range of 6 to 7. And in an article mentioned by Ken Slide in 2006, the bacteria that most of the bacteria are neutrophile, and neutrophile means that the bacteria grows at optimally at neutral pH, which is pH 7. Due to this reason, that's why the highest manganese removal occurs at pH 7. Next, we'll proceed to oxidation. Manganese oxidation, the control that we have chosen is negative control. It is nutrient broth without manganese added with LBB. For INAB10 at pH 7, at pH 6, pH 7, and pH 8, we can see that the intensity of blue color is higher than the negative control. It's the same goes to HKM06 at pH 6, pH 7, and pH 8. The blue color intensity are higher than the negative control. According to Barboza, under this condition, manganese oxidation was confirmed by the addition of LBB reagent. And based on my observation on the nutrient broth that contain the isolates and manganese, after 7 days incubation, there are some black precipitate formed in the nutrient broth, and I assume that the black precipitate is manganese oxide that being oxidized by the MOB. As for the conclusion, there are 6 bacterial isolates that were gained from the section 7 lake, which are INAB10, IHKM10, IHKM06, INAB03, and AKM01, and IHKM15. The suitable pH for the manganese removal that were obtained from this research is at pH 7. And at pH 7, the overall manganese removal for INAB and IHKM is 75.3% and 75.7%. This isolate has the ability to oxidize manganese into becoming manganese oxide that later can be removed by using the filtration process. The presence of manganese oxide were indicated by the intensity of blue color after adding the LBB solution, and the presence of black precipitate in the nutrient broth that contain isolate and manganese shows this research shows that the bacteria can be used to remove manganese in water, but also this research shows that bacteria that can be used to remove manganese in water can be found locally in Malaysia. The biogenic removal of manganese were successfully carried out with the bacteria isolated from lake water shows the phylogenetically diverse the manganese oxidizing bacteria. That's it from me. Thank you.